Good day, class. This video will help you understand the concept of phase change.
Also, this video will help you in computations involving phase change.
I'm teacher Joey.
I am teacher John Mark. Let's start.
Yes, let's start. What is phase change? We use the term phase to describe the states of matter, such as solid, liquid, and gases, like the compound H2O. Exist in solid phase, such as ice, in liquid state or phase, as water, and in gaseous phase, as steam. So, a transition of one phase to another phase is called a phase change. Phase change are physical changes because it only affects the physical appearance and not the chemical makeup. So here we have a diagram of the phase change of water. So, and it also, phase change is also reversible. So from here we have solid to liquid. We call that one melting. And then from liquid to solid, we have freezing. Then from liquid to gas, which is vaporization, and from gas to liquid condensation. Then from gas to solid, we call it deposition, and from solid to gas, which is sublimation. What happens during a phase change? During a phase change, heat is either released or absorbed. So we have here a diagram of water, of phases of water, from solid, liquid to gas. These arrows shows that the energy is being released and absorbed. So this arrow pointing to the left shows that energy is released, while this arrow pointing to the right shows that heat energy is absorbed. Okay, let's continue. So from liquid to solid, we call that process freezing. And that freezing involves, it is a process in which heat is being released, right? It is released. So meaning that heat is released, that the molecules are slowing down and it moves closer. While in melting, from solid to liquid, it is called melting. Yes, the heat is being absorbed because it melts, and the molecules are speeding up or it excites. Another process called decondensation. So from water vapor to liquid water. Condensation, the heat is being released. And the last process, evaporation, from liquid to gas, or which is the water vapor, that the heat is being absorbed. To change the phase of a certain matter, we need what we call the latent heat. So what is latent heat? Based on its definition, latent heat is the heat needed to change the state of body. So here we have a cycle of phase changes, and to change the phase of these three states of matter, we need the different latent heat, kinds of latent heat. So from to change the phase from solid to liquid or liquid to solid, we need this latent heat of fusion to change the phase. Yes. And then from liquid to gas and gas to liquid, we need the latent heat of vaporization. So this is the heat that is needed to change the phase from liquid to gas, or either liquid to gas or gas to liquid. And the last kind of latent heat is what we call the latent heat of sublimation. So to change the phase of solid from solid to gas and gas to solid, we need this latent heat of sublimation. So this kind of um, states of matter is applicable, for example, in water. And from solid to gas, we have the dry ice.
Earlier, the concepts of phase change was discussed, and now let's do some computations. We have here a question about latent heat diffusion. So how much heat is given off when 3.2 kilograms of water freezes? Assume that temperature stays constant at 0 degrees Celsius. The formula in getting the latent heat diffusion is Q is equal to mLF, where Q is the heat and M is the mass and LF is the latent heat diffusion, which is constant in a given substance. In this problem, we have the given 3.2 kilograms, which is the mass, and the constant latent heat diffusion is equal to 3.3 times 10 to the raise to 5 joules per kilogram. Now, let us substitute the value in the formula. 3.2 to the mass is 3.2 kilograms, and then multiply to the constant latent heat diffusion in water, which is 3.3 times 10 raised to 5 joules per kilogram. So the heat is equal to 3.2 times 3.3 raised to 5 is equal to so the heat that is given off when 3.2 kilogram of water freezes is equal to 1,056,000 joules. This time, we are going to solve problems involving latent heat of vaporization. So the question is, how many kilograms of steam will release 1,130 kilojoules when the steam condenses at the boiling point of water? So let us identify the given. So we have the heat, which is 1,130 kilojoules. And then the steam constant latent heat of vaporization is equal to 2,260 kilojoules per kilogram. So the formula in getting the latent heat of vaporization once again is Q is equal to mLV. Since the problem states how many kilograms of steam, so therefore we're going to find the mass. So let us derive the formula to get the mass. So let us divide both sides with LV to get the mass. So mass is equal to Q over latent heat of vaporization. So let us substitute the value found in this in the upper side. So Q is equal to 1,130 kilojoules. Latent heat of vaporization of steam is equal to 2,260 kilojoules per kilogram. So kilojoules cancel out. So let us compute 1,130 divided by 2,260. So the answer is 0.5 kilograms.